Hello everyone, in this video I'll be explaining you the problem product exceed. So you are given three integers x, y and p. In one move you can either increase x by 1 or increase y by 1. Find the minimum number of moves needed to reach a state where the product of x and y is greater than or equal to p. Okay, so in the input we have test cases, and for every test case we have three integers x, y and p. So they've given three test cases. So the first one is 5317. Let's understand this problem. So we have the problem as product exceed. So in the problem statement, what they've said is they'll give three integers, okay, which is x, y, and p. And basically the operation what they're saying is in one operation, we can either increase x by 1 or we can either increase y by 1. We can do um, any one operation, okay, not both in one operation. And we need to find x into y. If this is greater than equals to p, so in that case we need to stop. And how many operations we are doing, that we need to calculate it. How many operations is required are required to make sure this condition holds good, x star y greater than equals to p. So this is kind of a greedy problem, I would say, because um, whatever the x and value they've given, in the example they've given x as 5, y as 3, and the product as 17. So initially when you do x star y, where the operation is 0, it's zeroth operation, x star y, the answer is gonna be 15, 5 into 3. The first operation I would say, wherein I'll try to increase x by 1. So it's gonna be 6 into 3, which is 18. But if I do the other way around, so it's gonna be 4 into 5, which is 20. So as you can see, both the operations leads to, right, this thing. 18 is greater than equals to product p, which is 17. Similarly here also 20 is greater than equals to p, which is 17. So here it doesn't matter. Now once you take this second example, it is, and the product is 10, right? So here you don't need to do any operation. In the zeroth operation only, when you do x star y, it's gonna be 2 into 7, which is 14, and this 14 is greater than equals to product p, which is 10. So zero operations are required, but here one operation is required. So answer is gonna be 1 here, and here the answer is 0, right? Yeah, now let's go to the third one, example 3. So now the thing is, what we can do is, see, in the zeroth operation when you're not increasing anything, so answer is 9, greater than equals to p is wrong. Okay, it is not greater than equals to p because p is 29. Now, what we can do in the first operation, we can either increase x to x plus 1 or we can increase y to y plus 1. Now the question comes, which one do you increase, right? So greedily what we are going to do is we are going to, check if the product of x plus 1 into y is greater than equals to product of x into y plus 1. Basically what I'm doing is I'm increasing x here and y remains same. Okay, and we are checking with by increasing y and x remains same. So whichever product gives the maximum value, so we will lean towards that, which is obvious, right? So whichever product is giving you the higher product, so we will move towards that so that we get the product of x into y greater than equals to as soon as possible, right? So yeah, I think this was the main crux of the problem. So we need to just check this condition, x plus 1 into y greater than equals to x into y plus 1. So if you see the algorithm, how it's gonna be, first we have to create a while loop and we need to check until x into y is lesser than p. um, we need to keep increasing x and y and we'll take one variable operation which is initially 0, which means we have done 0 operations, but in this while loop we will do the operations, and when you come out of the loop we need to print the operation. Now as I said, we need to check if x plus 1 star y is greater than equals to x into y plus 1. So and in that case we need to increase x by 1, else which means definitely the product x into y plus 1 is greater. Okay, so if it is greater, then we need to increase, I mean we need to lean towards y side, so we have to increase y. And don't forget to increase the operation, since you're increasing x, either x or y. Here you're increasing either x or y, so in that case definitely one operation you're doing, so you have to increase. So yeah, this is just the algorithm and it's a greedy approach. So let's go to VS Code and code it up. So the input is, we have test case. For every test case we have x, y and p. So test cases have taken care of this position, and for every test case we're calling a solve function, and we need x, y and p, right? Yeah. Now we need to check, I mean we'll take one answer variable, or we can say number of operations. Initially it is 0. Why your x star y, the product of two numbers is lesser than the product required. So we need to check if x plus 1 into y, if it is greater than or equals to x into y plus 1. So you need to increase x, because increasing x is giving the higher product. Else you need to increase y, and don't forget to increase the number of operations. Since you're increasing x and y, definitely you have done one operation, so you have to increase. and at the end we need to print the number of operations. So yeah, it got sample test cases got passed. Let's try to submit in the online editor. So yeah, this one also got accepted. If we try to analyze the time and space complexity, so as you can see, uh, the time and space complexity depends on the number of operations. So in order to reach the product P, you'll be increasing either X or Y. So here you can say the time complexity is basically linear, you can say. Okay, so your time complexity is linear and space complexity is constant. We are not using any extra space. So yeah, thank you guys for watching the video.